Alright, what's up everybody? Welcome to the first official video in my Minecraft Let's Play series. As you can see, I have already created my very first house, my dwelling here, and I have a few of the essentials inside, and for whatever reason, I don't know, I like the view, I like the heights, I have decided to settle on the top of this cliffside here. Let me show you around my house so far. So if we go in here, we will see that I have all of the essentials, a bed, a nice glass sunroof, and a massive painting that is covering up part of my window here, and a little bit of a furnace to cook food and whatnot. So, I decided today in this video that there is this naturally generated floating island over there. For whatever reason, islands decide to float in the middle of the sky in Minecraft. So what I'm going to do today is I'm actually going to start to build a bridge over there today. And let's just start with that. I got to be very, very careful here. Stand on the edge, place a block, and I'll get my bridge going here. Alright, so since I am a science teacher, I had a little bit of a thought as I was building my wooden bridge over to this floating platform here. I did think to myself, hey, I wonder if I could calculate the gravitational potential energy of my Minecraft character as he is standing on top of this raised platform. You know, I wonder how hard that would really be to figure out in Minecraft. Well, why not jump into it? Let's see if we can figure it out. So the very first thing we got to ask ourselves is, how do we calculate gravitational potential energy? What formula can we use to figure that out? So for instance, let's go back to our handy-dandy formula that is included in our potential energy notes. That was the very first notes that we took for the energy unit, and we should figure out that gravitational potential energy can be calculated by a very simple formula, and that formula is ham. I know it may sound silly, but if we remember that ham just stands for the height multiplied by the acceleration, multiplied by the mass of an object, we can figure out the gravitational potential energy of anything. So in this case, let's figure out my character's gravitational potential energy. Alright, so to calculate gravitational potential energy, there's a few variables that we need to figure out. The very first variable is, well, what is our height going to be? When I'm standing up on that wooden bridge, what is my height? And the nice part about Minecraft is that if we actually look at the scale of all of these blocks, we actually can figure out, and this is actually done by design, that these blocks are 1 meter across. These blocks are 1 perfect cubic meter. So this side's 1 meter, the height is 1 meter, and the width is also 1 meter. So the nice part is, if we just count up all of the blocks, we should actually be able to easily figure out what our height is in meters. And coincidentally enough, I've already done this for you, and we know that our height is going to be 60 meters here. I've already counted it all the way up, so from sea level or from ground level down there, if we count all the way up to right here, if I was standing on top of this platform, I would have a height of 60 meters. So that is our first variable that we know right there. Right, and the next variable that we must figure out is the acceleration in this problem, and that is the acceleration due to gravity. So we need to figure out, if we're calculating gravitational potential energy, what is the acceleration due to gravity? And we're just going to assume here that our Minecraft world is actually going to follow the same rules and it's going to have the same gravitational pull that Earth does. So if it has the same gravitational pull that Earth does, then we can assume that the force of gravity pulling down on my character at any given time, that acceleration can be measured as 9.8 meters per second squared. And then finally, because I do not have any digital scales or electronic balances in Minecraft, at least none that I know of, none that I could build, I'm just going to tell you that my character here, Steve, is going to have a mass of 62 kilograms. So he's going to have a mass of 62 kilograms, which is roughly about 155 pounds, give or take, if we wanted to convert to imperial units. Alright, so we just established the variables for our problem here, and we know that since we counted up all of the blocks from sea level all the way up to the top of the cliff, we know that there were 60 blocks, therefore we have a height of 60 meters because each block is exactly 1 meter across. So that's nice there. We know that bit of information. We also know that the acceleration due to gravity is just like it is on Earth, and that is going to be 9.8 meters per second squared. And finally, we know that our character Steve here is going to have a mass of 62 kilograms. So with all of this information in hand, all you have to do is plug in your variables to the equation here, ham, plug them into the equation and solve, and you can plug this directly into your calculator if you would like to as well, and you should get that gravitational potential energy is going to be 60 multiplied by 9.8 multiplied by 62. And when that is all said and done, you should get that your gravitational potential energy is going to equal 36,456 joules. Remember that we measure energy in joules for this class, so anytime that you see a unit for energy, just assume that we are going to be using joules. Anytime we calculate gravitational potential energy, or kinetic energy, or thermal energy, which we will do as well, you need to make sure that you are including joules as your units. No naked numbers in this class. So we just figured out that the gravitational potential energy of my character is going to be 36,456 joules if my character is going to be about 60 meters up in the air. But what happens if the unthinkable happens and my character accidentally falls off? I mess up and I accidentally fall off of the platform. Can I figure out the other type of energy that we talked about? Oh, hello, Mr. Dolphin. Can I figure out the other type of energy that we talked about, which is kinetic energy or moving energy? So we just calculated the gravitational potential energy, or the stored energy due to gravity. Now can we figure out the kinetic energy of my character right as my character is going to impact the water? So that right there, that brief instant, right before I make contact with the water, can we figure out what the kinetic energy of my character is going to be? Well, realistically, we probably could. There's just a few things we have to figure out first. The very first thing is, what formula should we use here? And if you think back to your notes from our very first day of notes, Concept 1, which is the nature of energy, we talked about the formula for kinetic energy, and kinetic energy can be figured out by using the equation 1/2 multiplied by the mass multiplied by the velocity of an object squared. So 1/2 mv squared. So realistically, if we know the mass of the object and we know the velocity or the speed of the object at any given point, we can figure out the kinetic energy. So in this problem, we already know one of the variables because we did it in part 1. We know that the mass of this character is going to be 62 kilograms. But because I do not have like a radar gun or anything like that, or a motion detector like what we use in class, I really am not going to be able to figure out my exact speed unless I tell it to you. So, in this case, what we're going to say is, as my character here is falling, I am going to reach a max speed right before I hit the water of 34.3 meters per second. 34.3 meters per second. So we just said that our kinetic energy formula is going to be 1/2 mv squared. We know based off of the first problem that our mass is going to be 62 kilograms for this character, and the character is going to be moving at 34.3 meters per second right before they hit the water, right before impacting the water. In that brief moment, that is going to be the final speed, 34.3 meters per second. So with this information, we can plug it directly into our equation, and we should get something that looks similar to this. We should get that we have 1/2 multiplied by 62 multiplied by 34.3 squared. Now, the next thing you should do is probably follow your order of operations. Remember, please excuse my dear Aunt Sally, or purple elephants may destroy Alexander schools. That means you should solve the exponent here first, because realistically, there's nothing in parentheses that needs to be taken care of to begin with. So, realistically, I would start with the 2 here, the squared, and what you should get is that kinetic energy will equal 1/2 multiplied by 62 multiplied by 1,176. That is going to be 34.3 squared. So once we get those values, we can then finally solve. We can plug this all into our calculator, and remember, 1/2 can be entered as 0.5 or 0.5 into your calculator. And if you multiply all of these values together, you should get that your kinetic energy equals 36,456 joules. Now, if you were paying attention to both of those problems that we just did, you should notice one thing, and that one thing is that they both had the same answer. Our gravitational potential energy and our kinetic energy were both 36,456 joules. And what we need to ask ourselves is, why is that happening? Why does that occur? And the easiest way to explain it is due to the one important thing that we talked about in our energy unit, and that is the law of conservation of energy. The law of conservation of energy states that energy is never created or destroyed, it can only change forms. So in this case, what is happening here is my Minecraft character standing on top of the bridge here, right there, has gravitational potential energy. Specifically, we know that my Minecraft character has 36,000 joules, give or take, of potential energy, And we know that immediately, once my character falls off the platform and starts moving, that all of that gravitational potential energy is being directly transferred into kinetic energy. That's where the law of conservation of energy comes into play, where that potential energy is being transferred or transformed into kinetic energy. So energy is never lost or destroyed, really. It only can change forms, and that is being demonstrated by this problem here. That is why we can say that our gravitational potential energy should be equal to our kinetic energy, and that is why this works. Alright, so I wanted to end the video by showing you my completed efforts here. I have finally completed my bridge, and I have made it to the floating platform here, and now I have plenty of room to expand and build on. Maybe I could add on an extra wing to my house. And, well, oh, there's a chest here too. I forgot about that. Let's finally see what's in this chest. Could be something really good. And it is dirt. So nice, I got myself a block of dirt. That will be very useful when I'm trying to expand here and build out my platform. So that is going to end it for this video today. Hopefully you enjoyed this video. Hopefully you also learned a little bit as well. If you really like these videos, I hope that I can make some in the future. I'm going to do my best to relate it to the content that we have been learning in class. And if you really enjoyed this, leave me a thumbs up down there as a like. And if you really want to help me out, you can subscribe to the channel. That way you get the notifications of every single time that I post a new video. So thanks for watching, and I'll see you next time.